We have a problem.
What?
I have bad news to report. We're using too much on manufacturing.
What? What should we do?
We can optimize soup cans. After measuring our soup cans, we saw that our height was 110 millimeters and our radius was 37.5 millimeters. To start off, we wrote out our volume formula, plugged in our height and radius values to calculate our volume of the soup can. After knowing the volume, we could then isolate h by dividing both sides by pi r squared. We then wrote the surface area formula and went on to plug in our h value. After simplifying, we then took the derivative and then set it to 0. After solving for r, then we plugged in our value for r back into the volume formula to find h. Then we calculated the new surface area. What do you think?
You're fired. Wait, why don't we optimize cardboard boxes instead? After measuring our box dimensions, we found our dimensions, plugged them in, found our volume, and then solved for the variable h. I then substituted my h value into the surface area formula for a rectangular solid, simplified it, and took the derivative. After setting my derivative equal to 0, I then found my b value, in which I took it and then plugged it into the volume formula to find my h value. However, even though we kept the volume while optimizing the surface area of the cardboard box, we realized that we wouldn't be able to fit the same number of soup cans from our original box to our new optimized box. We would then have to make sure that the number of cans we could fit in our optimized box would be more than the number of cans we could fit in our original box. We know that our diameter of the can is 7.5 centimeters and our height is 11 centimeters. We started first with the original box dimensions. We took the height of the box and divided it by the height of the can to find the number of cans we could stack up high, and we got 4 cans. We then divided the base of the box by the diameter of the can and got about 2 cans across. Because we have a 3-dimensional figure and the size of the base are the same, we did 4 times 2 times 2 and got a total of 16 cans altogether. We then did it again, this time with our new dimensions, and got 18 cans. So even though we optimized the surface area but kept the volume, we saw that the new dimensions would change the number of cans to fit in the box. Luckily, with our new dimensions, we could fit 18 cans as opposed to the original box dimensions where we could only fit 16. Therefore, not only will we use less material, but we can add more cans. Here you go!
Together, we can save the environment.